Week 3. So today we're going to look into trying to understand your code a little better. At any point, if you don't see my screen, the screen sharing stops, let me know. The first thing, let's do a quick recap. First week, we did how to turn an idea into a prototype, just quickly get something out there. Week 2, we looked at how to turn prototype into high fidelity versions using all those 4 techniques that I showed you in terms of how you can take images or use CSS or use these MCPs and all of that stuff, right? So week 3, we are going to look at how can you make your application interactive in terms of where is the data stored? How do you add interactivity? Most of you already have added interactions to your application, but now we're going to take a look at what happens behind the scenes when you add an interaction so that you know where the data flows and what exactly happens in your app. To do that, it helps to understand some basics of JavaScript. If you remember, we have HTML, we have CSS, we have JavaScript. These 3 combine to create your web page. JavaScript is like an entire language that people learn for years together, but we are not going to go into too much technical details. We're going to go into just enough conceptual details so that you can understand if something breaks, or you can go into your code and like clean things up. The first concept of JavaScript that I want to touch on is variables. So variables are the same variables as your Figma. I don't think this needs like a detailed explanation. It's like a storage box or a container in which you can like store values, change values, and all of that. The one thing you want to pay attention to here is that there is a syntax. Like, how is a variable written in code? It looks like this in JavaScript. So there are two types of variables, it's called let and const. So a const is a constant, which means when you say age is 25 as a variable, this value will never change across your application. So imagine things like if you're building a food delivery application, a const could be the details of the restaurant, like the name of the restaurant, right? So it would be like const vendor name equals the name of the restaurant. So the vendor name will never change. So it would be the same across your entire application. And let is something that could change. For example, form elements. So if you have a form that people have to fill, and when people say enter their address, that gets stored in the let variable. And then when someone changes at some point, if they change the address, the variable changes, right? So that's how the code decides if the value should be stored inside a const variable or a let variable. Okay. Please stop me anytime if you have questions. Yeah, it's better to get it clear than just have a vague understanding. So as you see, there are like different kinds of data that could be stored in variables. So text, number, Boolean are the most common ones. There are a lot more. But what we do is we need to understand that this type definition is something that's important for the application to know what kind of variable to store and how to refer to this variable later in the application, right? So if in the errors you get something like these types are missing or something, then you know that maybe there is a mismatch in terms of what is being stored in which variable, or the type definition is not available. It's very unlikely you're going to have to deal with types. Like AI will do all of this for you, but just helpful for you to know what are the different types. Functions are all over your application. Functions are like the most fundamental way how your entire application works. A function is like a defined action which has a specific title to it, right? So in this case, package order is a function. And within package order, we are nesting more functions. So we are saying for inside package order, you add items to the box, then tape box, and add shipping label, then approve for shipping. So these are all different functions within this package order function. And it executes, when you have a function, it executes from top to bottom. So when you call this function on the bottom that you see package order, when you call this, how your code goes is it goes from top to bottom. The moment this is done, it goes from top, it goes and adds items to box, it finishes this, then it goes into tape box, it finishes this, then it goes into add shipping label. The advantage of these functions is that they're reusable, right? So in your app, you could have something like handle submit function, which is a function that just decides what to do after you fill up a form and then say submit. right? And the function will be called handle submit. This you can see like quite often. I can also show you, like, for example, if I just say, if I go search for handle submit, this is such a common function that you can see in most applications. Just to give you context, this is the code for this application, CSS, that someone in this community is building. You can see that get note at fret is a function. And it looks similar, except if you just remove this, you can see that it looks very similar to how this looks, right? Function is defined inside a variable, and then there's this brackets, and then followed by this arrow. This is how it looks. And then what the actions are is inside this curly brace. This is called a syntax. You can see very similar things. So in this case, get note at fret is a function. And the moment you look at this, you know what it's doing. It's creating a definition for this function, and somewhere in the application, this function would be called. If you just go and look for this, I'm just going to copy this, and then I'm going to, okay, I think something is wrong with my laptop. Okay, so I'm going to paste this. So you can see that here it's getting called. So it's getting a note by calling this function, and then that value of that result of that function call is being stored inside a variable. It's one piece of a bigger system that's working. So you don't have to connect all of them and understand how they work. That's what AI does, all of that for you. But it's just useful to know what a function is and what it looks like, basically. How you may use this knowledge. One of the biggest problems that I've seen when you're building applications at scale, like when you're building larger applications, is that these functions are meant to be reusable. So wherever you're trying to use this package order functionality, it should use this function. But then sometimes what it does is it creates new functions that have the same purpose in multiple different places. And that is just unnecessary bloated code, which is kind of one of the drawbacks of like AI, which is there today, that it creates all these unnecessary code in different places without knowing that there was a function that already existed for that purpose. So this is one very critical use case for which you can understand that later at some point you could be like, hey, can you check if these functions are used elsewhere? And then what it would do is just go look at package order. It will search in your code base for other package order functions. And then it will be like, hey, I found this package order in 10 different places. And let me gather them all together and just make it one. And then just share that same thing across. So this is a very frequently occurring use case that I've been facing when I'm building. Yeah, Sridhar.
Is this package order one of the folders in Cursor? Can I just quickly go to this folder and check what functions are defined?
Yes, you absolutely can. So you can just copy and search this, right? So you can search over here, and you on the left, you can see all the different places this function is called. You can do that, but sometimes what it may do is it may not create the same function with the same name everywhere. So when I'm on a different page, you're saying, hey, I want to get the interval color in the second page, right? Or the third page. So what it may do is it may create the same function, but call it something else. It may call it like get color interval, for example. So if you go and search, copy here and search from there, you probably won't be able to find the same thing. But if you search in AI, be like, hey, where is the similar function? Is it defined somewhere else? What AI does is it does a different kind of search. Okay, it does a vector search, and a vector search is actually pretty cool because even if you swap the things, like when you say get color interval and get interval color, it will know. It will figure that out for you, and it'll know. Also, it'll have a look into what the contents inside that function is. So it will find the duplicates very effectively. So you could technically do a manual search, but it's better to ask AI to do it. Did that answer your question?
Yeah, it did. Thank
Okay.
you.
Sure. So I've been building this restaurant application, like a whole food ordering application, and it did this so many times. Hold on, I can open it for you. Open recent new window. So in this project that I'm building, you can look at it and you'll know how complicated the application is, right? Because it does a lot of things if I open it. So it's like a whole pizza delivery application. So when you just go and add things, like you add to the cart, and then you go and sign in, and then so it does a lot of things. But when I was building it, what it did was the same functions that I was executing on the home page, it was recreating it in the checkout page. It created a very similar function in my orders page. It's created very similar functions in the checkout page. So there was just a lot of recreation that it was doing. So all I did was just to go be like, hey, look at all the functions in my application and see if there are any duplications. So that significantly improved the experience. Okay, let me keep moving. Objects. So objects are like, it's a collection of information tied to a specific purpose. So in this case, it's recipient, right? So recipient has a name, address, order date, and all of this. So on the left and right, what do you call it is a key value pair. So this is a key. Every object looks like this. It has a curly braces, and it also is assigned to a variable. And the key is, it could be anything. So it could be name, address, phone number, anything, right? So everything, it's a value. This is a key, and this is a value assigned to that key. So you could, to find that specific value, you could say recipient dot name, and it will pull out this information. That's basically how the code stores different information. So for example, in this food delivery application, there would be an object that has all the list of items in the cart, right? It will have an object that says, okay, pizza 1, pizza 2, pizza 3, pizza 4, right? So all of this will be stored in an object file, and that object file is how I know exactly all the pizzas the user is ordering. And then that same object file is what I would store anywhere. It would store in my application, either in the database or in locally, and that same object file is with which I use to place an order. So you'll find this objects like in a lot of places. So all you need to know is like how to know when you detect an object, right? Next one, events. Events are like how you interact with applications. So in this case, it looks something like this. So there's a button, and then there are all these properties for each element. So every HTML element has an event, right? There could be a scroll event. There could be like click event. There could be hover event. So each HTML element has these different list of events. And when this event happens, this function will get executed. That's what the syntax is. So when there's a button, add this event listener, and the event listener name is click. So when I click this button, execute this function, mark delivered. So this is how basically it creates different events in your page, and it does all these actions. How would you use it? So let's say you're building a landing page, and you want your elements to move based on your scroll position, right? This is a very common use case that we use. Instead of saying, I want the elements to move, which will most certainly work, but you could also say that create a scroll event on this page. So as the page scrolls, move these objects in the same scroll speed as my scroll, for example. That's a more technical way to say the same thing. And it's more effective when you're building multiple scroll events, because let's say by accident it created multiple scroll events on the same page, your whole page is going to be very slow because it's doing a lot more processing at the same time. So you could say something like, see if there's already a scroll event going on in the page, and if it is, connect it to the same scroll event, right? Instead of creating a new scroll event. A small chance you'll have something like this when you're building larger applications and your application is continuously breaking, or it has some unexpected glitches. This is probably why it's happening. So just good for you to know that there are events happening all over your website. So at some point you could ask, okay, what are the events that are there? Is there a scroll event? Is there a click event? And all of that stuff, if you want to debug. Okay, so that was like the basics of JavaScript. There are so many things, but I'm intentionally skipping a lot because you probably would never have to code yourself. But we're just touching on the important concepts. So intro to React, right? So all your applications is built on React. everything. Right? So React is driving most of the web now. So one thing you need to understand is like there is a certain mental model behind React in why it got so popular, right? The whole mental model is around components. It's the same as your Figma components, and the same concept applies to React. And in Figma, you have components for a button, you have components for input field, you have components for little things. In React, you can have components for varied types of use cases. You could have a component for an entire website inside a website, or you can have a component for a simple button, or a component that's just some logic. It's just a logic around how forms are validated, for example. So there are so many components that you can create, which is purely UI, purely function, or it could be a combination of UI and function. It could be so many different ways of creating components in React. And that's what made this so popular, because people could create all of these components and share with others. React has the biggest library of components out there that you can just reuse. So most things that you're doing on your website, right? So you're doing, for example, the whole idea of rearranging information, right? So the drag and drop thing that you had, Sriraksha, where you were just doing this like rearranging cards in the left side panel. That's a component. Like someone would have built a component called, I believe it should be React DND. So let me look at it, React DND. So this is a component. See, React drag and drop for React. Let me open this. Okay. See, so you can do all of this, like this thing, all of these use cases. It's all built on React DND. So when you say, I want to just like move cards, all you need to know is that like the chessboard depends on this ability to drag and drop, but it works behind the scene. This component is what powers it. Your application would use React DND to implement a very similar functionality. So you could go and look at what are the different components you have. So you have so many different, you have components for pretty much anything that you can think of. You have components for drawing on canvases. You have components for creating music. You have components for everything. Like most of the games that I did are all like some component somebody created and just adapted it, right? So this is how your entire React works in combination. So each block has a purpose. So it's like each component has its own purpose. It could be a UI, logic, or a full-blown app. And ultimately, you combine all of these to create a bigger working application, right? So just to give an idea of what it looks like in code. So back to what I mentioned at first, where the whole web browser, every website is powered by HTML, CSS, and JavaScript, right? So vanilla JS is the same as JavaScript. So ultimately, from React, you're going to convert it into JavaScript for the web to read. So it'll always go into JavaScript only. But how you are coding or how your AI is coding is on React. So that's the code in which we write. But then when you compile it or when you build it, it turns into a JavaScript, right? So the reason we are doing it here is that it's so much easier. So if you see over here on the left, there is a document. Document is your entire page, your entire website. And there is an event saying get element by ID. So it's a selector. It's called a selector. So it'll pick an element by ID and it'll pick this based on this ID name. You would have defined this ID on a button or on any element on the page. And then you're adding an event listener and you're saying like, when I click this, do this thing, right? So this is super complicated if you don't know the basics of JavaScript, and if you haven't coded, this is so very complex, and it also very wordy. So there's more code, it's scattered across the files, and you can see that you have to write this as many number of times as you have buttons. Yeah.
Next is also similar to this vanilla JS, or how is that related?
Yeah, so Next.js is a framework. We are coming to that. So this is just, Next.js is built on React. So vanilla.js is the lowest level thing. Everything is compiled to vanilla.js. Then there is React that compiles to vanilla.js. And then there is Next.js that is built on top of React, right? So it's a framework. We'll come to that. It's in the next slide. Yeah, So the issue with JavaScript is that it's hard to copy paste. You'll have so much more code that you have to manually write. It's just not scalable for, especially for AI tools, because it has to write more tokens, it has to use more tokens and all of that. So the same logic on React just looks like this, right? So the counter is one packaged component, and all the functionality of that counter will be inside that thing. And you're just using this one counter and you're reusing it as many times as you want. So it's the same thing. So if you see on my UI, list of UI, you can see all of these are like components, right? Button sign in is a component, button popover is a component. And you would just use this button popover like exactly the same way. So let me just look for button account, right? So you can see that button account is a component. And if I open here, see, button account is a component. And I would use that button account in different places. So inside header, I use that button account. I'm importing that button account from this page. And then I would use it within this page. Sorry, button account. So I would use it in different places inside this page. There you go. See, I'm using the same button account. If it's authenticated, show this button account. That's basically what this logic is saying. And I'm using this same syntax, right? So this is exactly how it's written. So when you see something like this, you know that it's a component somewhere on your page that is being used. And you'll find this all over your page. See, phone is a component, map pin is a component, button sign in is a component. So all over your page, you will see this. Things like span, div, these are HTML tags. I think if you remember, we spoke about it on the first week. So you can see components everywhere. So image is a component. That's how you know if something on this page is a component. Button here is not a component. Button here is not a component. It's just a simple HTML. How do you know? Just by looking at the first character. If the first character is a uppercase, it's a React component. If it's a lowercase, it's a HTML component. That's one trick to know if it's a React component or an HTML, just an HTML tag. So you could be like, hey, why is all this button repeated? Just create one component and use the same component for all these buttons. It's a perfectly valid thing to say, and you can correct the AI's decisions and make your code much cleaner, make your application much faster. There are lots of benefits to doing this. Your application will load faster, even your interactivity will be faster. There's so many benefits to this, right? So that's what the current limitation with AI is it creates so much unnecessary code that you can just reuse and save a lot of speed and performance. Okay, Node.js. So Node.js is basically the environment on which your React runs. So you need your Node.js installed in your computer, and your React runs in Node.js. So I think if you are running Cursor, you know that you already have Node.js. If you don't, you can open your terminal, and then in your terminal, you can just type node_v, and that will show that you have Node.js installed. So if you show something, you have Node.js installed. The reason we use Node.js is because through this Node.js is how you bring all these React components from online to your application. So there is something called as a Node Package Manager, which we're just going to go right now. So in this Node.js environment, you're adding packages to your application, and that's what managing packages mean. You're adding packages through your application, and it powers your development. So without Node, you won't be able to work with your application and do things with it, right? So that's what a Node.js environment is. So all you need to know is that you need this environment installed for your React to work, basically. So React frameworks. See, these are just concepts, right? Concepts for you to know, and concepts for you to know in terms of why something is happening. Sometimes you may not even work with this level of conceptual level in your application when you're doing things, but it's just good for you to know what's happening behind the scenes. So here's where our frameworks come into picture. So frameworks are now there is JavaScript, now there's React, and now there's a React framework. A React framework is what it does is it takes care of a lot more decisions for you upfront. So with React, you can create all kinds of things. You can create not just applications like web applications. You can create, I don't know, these things that talk to Internet of Things. or you can do so many things you can do within just a React framework. You can run React on any device. But these Next.js and Vite.js are like the two most popular React frameworks that makes some of these common decisions that you make for building applications, it makes it into a template, basically. So Next is, I think, one of the most popular frameworks. And the reason it's so popular is because it creates what it's called as the API imitation. So whenever you, from an application, you try to do something, it goes and talks to an API and it pulls data and then it does something with that data, right? So this data pulling and fetching is defined within the application as a template. Like, where do you write your APIs? How do you define your APIs? So all this logic is all written within Next.js that makes it so much easier for developers to build on top of. But again, you're not going to be using Next.js, as in you're not going to be writing Next.js, your AI is going to be writing for you. But good for you to know that if your app is built on Next.js or app is built on Vite. Each one has its pros and cons, right? So Vite is what Lovable uses. Next.js is what V0 uses. So if you try to generate an app on Lovable, it'll generate it on Vite. If you generate an app on V0, it'll do it on Next.js. And if you look at Vite applications, the advantage is it's faster and it's much lighter, which means there are a lot of functionality that doesn't come out of the box. Things like routing, things like when you go from one page to another, like what is the logic? Like how do you implement that logic? There could be lots of React components that helps you with that logic. But Next.js will have already defined it. Next.js will be like, hey, you don't use other React components. This is how you have to do this routing and always follow the same thing. So Next.js comes with a lot more opinions, but Vite comes with like very little ones. So Vite is best for like little prototypes. So because you're not going to have so much functionality, you're not probably going to have, you just maybe want to make quick landing pages, for example. So there is no data flow. So for something like that, Vite is much easier because your page will be faster. You don't have all this unnecessary code. But if you're building a full-scale application, Next.js is a better place to start because you know all the functionality that comes within is something that you are going to use. So Node Package Manager. This is something that I think if you notice, if your AI has executed this command several times, what it's doing is it's adding all these packages to your application. So for React, drag and drop is a package. So when you say npm install React DND, what it'll do is go get that package. The Node environment is doing that for you. It's getting that package from online, and then it's going and putting it in your app, and it's installing in your application. That's what it's doing. So you have all these packages easily accessible from that Node environment. So you can say npm install Framer Motion, npm install React icons. So when you see all these packages, and you can see all the packages that you've installed within a file called package.json. So if I open this package.json, you can see all the different packages that are installed and this application uses. It uses, you can see React hook form, React hot toast. It uses, so it uses all these packages, and all these packages were installed through that command, through npm install headless React, npm install hook form. So that's basically what happens under the hood. But you don't do this installation. It comes pre-installed in your Lovable app. But if you want to install something new, when you tell AI, hey, I want to implement this drag and drop functionality, it goes and finds the right package for you to do this drag and drop functionality and then integrates in your application. Yeah.
If I want some animation in that journey component, then can I go and check some inspiration? Like, how does it work? Does it have anything to do with packages, or is it some other way?
Great question. So that's what, there are so many different ways that you can implement animations. You can implement through Framer Motion package, or you can implement through GSAP package, or you can implement through like just some other different package someone else wrote. So you can, to an extent, when you don't specify this, and when you just say, I want this to be animated like that on AI, it makes a decision for you. It will decide, okay, based on what you ask, Framer Motion might be the best decision, best package to bring. And that's completely fine. But then what happens is the next time, some other time in your application, you're asking for a different animation. What AI won't know is that the previous time you asked for framer motion. So the second time it may be like, hey, okay, to make this animation, I'll get a different package. I'll get GSAP package and do it for you. Now, for the same purpose, in this case, the problem is you're using two different packages. It's inefficient. It's just unnecessary bloated code. So when you know that you've installed framer motion package for your motion stuff, at any other point, when you're trying to create animations, you can be like, hey, create this animation with framer motion, right? So you can be more specific about, you can be more mindful about how much you're adding to your application. Like just keep your packages clean, right? So why would you like add unnecessary functionality? So yeah, to answer your question, you can define which package that you want for what animations. There are some like very popular ones. Framer motion is super popular for animation. So most people just use framer motion, but depending on complexity of animations, you have other packages.
Cool. I have one more question on Next and the framework you were talking about. What does it do exactly if I want to add an add feature? Is it going to be the Next.js part that is going to do it, or is it going to be React that will do the add function within my application?
But what do you mean by add function? Do you
Let's say I just want to add, let's say I just have a calculator add, right? I want 1 + 2 = 3. So what is it that does this?
Got it. So things like simple calculations all happens at a JavaScript level, at the lowest level. So you write code in React, and that's where you will write a function that says add values is be a function. And within that function, there'll be a logic that says take the input, take these two input values, add them, and give this output, right? That function will be defined with its purpose to add two things. And this function will, if you use that addition in several different places in your application, it will just reuse that function in several different places. So to answer your question, it happens, we write it at a React level, but then it compiles to JavaScript, and JavaScript is what knows how to add things. So JavaScript has all these like basic mathematical operations integrated. So it has addition, subtraction, string manipulation, and all of that stuff. So Next.js and React, so Next.js is just a framework, right? So Next.js doesn't do the addition. The Next.js is just a way your React components are kept within this whole application. So the function itself is written in React. Does that make sense?
Yeah, much better understanding them. Yeah.
Sure, but good question. Yeah, it's useful to understand because you need to, these terms can get like really confusing, what is Next.js, what is React, what is JavaScript. That's why trying to give a more visual picture, right? So JavaScript is the lowest level language. It's what like does all the operations on your browser. React is how you write JavaScript. It's just another way of writing JavaScript. And Next.js is how all these React components sit together for a bigger application that you have, right? So an application has so many different functionalities. So it takes all these functionalities upfront, out of the box, so that you don't have to define all those functionalities or use other components and all of that for simple functionalities, basically. Okay, let me keep moving. So how React works. So this is how a typical application would look like, right? So your app.tsx is one big file, one big React component. And within that React component, you have a header React component. And you have a products list React component. And within products list React component, you have a product card React component. So if you can see, this product card React component is just being repeated like multiple times. So there are several copies of this product card in your application. And that's how I see, for example, the pizzas I showed in my food delivery app. Each pizza will be a pizza card, for example. And the same copy of pizza card will be repeated multiple times. And the whole wrapper of the entire pizza card, the whole menu, will be called like pizza menu.tsx, for example. And then .tsx is the file extension. And you can find all of this, like, it's all the same thing. So if I go into my application, see all of this are TSX. So if you see within my components, .tsx. So testimonials, tabs is a component. Pizza model is a component. So everything is a TSX file. And yeah, so what React does is it nests things under. So inside the product list component, you're passing all the cards, and it sits inside it. So that's how your application is just like a whole outside to inside packaging. So everything is just stacked one inside the other. So it's like box inside a box. So this is how like your high level architecture works. So when you see a tree diagram like this, so you can go to your application and you can actually see your entire tree. It's actually pretty cool that you can do that. So you can go to your application and show my application tree. And what it'll do is it'll go look at your entire code, and then it'll say, okay, this is how your whole application tree looks like. You just give it just a second and let's take a look at it. So it's going and checking all the different files. It's going looking at apps, components, and it's going and listing all of this. And it will create this, yeah, see? So Moini Next is the entire application. And then within this application, now there is an app folder, which is what the highest level wrapper. And within this, there is a page, which is the home page. And there is the layout, which is the root layout. And then there's the global CSS. And then there is an API folder. And within that API, there are different functionality within API. For authentication, there's a thing. For lead generation, there's a thing. For payments, there's a thing. And then there's an admin, which has setups, orders. And so you can see that all of this live inside the application wrapper. And within the application wrapper, there's a components. There is like, for within components, there are all these components. So this is basically how your whole application is organized within your code base. So that's React. That's the structure or the architecture of a React app, right? So this is important for you to know. There's a concept called props in React. So for you to know which products or which cards should exist inside this product list, you need to pass some value, right? You need to pass this information that there are 3 products within products list, so that it can display these things multiple times, right? So this is a prop. So you pass values, right? So in the header, you pass a value that says either logged in or logged out. And when you pass this prop, it will show the state. It will show a logged in state or logged out state. Similarly, the whole application will pass 3 products inside the product list. And then within this product, you'll have maybe a counter. So there are props going from outside to inside, right? It always goes from outside to inside. It never goes from inside to outside. So the data flow is always, when you load the application, it loads all the data first, like what it needs to do. And it sends the information from outside to inside. So I hope I'm trying to explain it visually. So if I actually go to my application and show you, okay, let me open the one, right? So yeah, so for example, this whole application will have like the most outside wrapper, right? It'll have things like, is the user logged in? What's the user's name? What are the different cards to show? It'll have all of that information from the outside wrapper. And when it comes to the inside wrapper, to this one, all that information gets passed out. So there's actually a plugin which you can use to visualize this, and it's called React Component Plugin. So you can download it, and you can see this is how all the components are defined. So everything goes from outside to inside. That's why you see this pattern, because everything is like from outside to inside, right? So functionality related components. So that's why not all of them make sense to you. So for example, header, right? Header is sitting inside the app root component. Here's the app router component, right? So now within header, you can see that there is if I just hover, you can see on the left which one each one is, right? So this is a link component, which is just the logo. And then within logo, so within header, you can see that there is some information being passed. There's some prop being passed. And what prop is being passed into the header? It's the user information. It says stuff like if the user is authenticated, when was the last sign in. All of this information is being passed into the header. Once, like with this information being passed, this component renders. So this component says, look, we need to show that the user is logged in. So this is like the information flow from outside to inside, just something for you to know. You would probably never have to write logic for like how components data flows, but just like behind the scenes, like what's happening in terms of the entire architecture. Okay, so React state. So this is where things are a bit useful for you to understand, right? So where does all your data that you store, the data in your website get stored? So it has to store either locally on your application in your browser, or it has to be stored externally in a database, right? So React state is how your information is stored locally. So within your application, when you enter a value in a form, this value is stored inside your application, and it's stored using a code that looks like this. Basically, this is the syntax. So you're creating a const and you're creating a constant, similar to how you saw in JavaScript when I explained constants and when I explained variables. So this is exactly that, but this is the React version of variables. So from JavaScript, now what React does is it gives you a variable, and it also gives you a function with which you can set that variable. So when you write something like this, what React does is like, it says, look, quantity is a new variable that I want to create right now. And set quantity is a function that I will use to set values to the quantity. And use state of 0 is basically, when you say use state, you're saying I want to use a local storage mechanism. And 0 is like the default value. So I'm saying, look, start with 0 as a default value. Whenever I set a quantity, so when I call this function, I say set quantity of 4, the value of 4 will be stored inside quantity. When I say set quantity of 6, the value of 6 will be stored inside quantity. So basically, every page will have this sort of thing, right? So I can show you inside the code. When I go into my header, you can see if I scroll down, it'll be the first thing on the top. So you can see, is menu open? Is menu closed? And then you say use state false. So when you open the menu, you can change this to true. And anywhere in your application, when this becomes true, you show the menu sidebar, something like that, right? So that's how it uses state to know what values should be stored within your application. Now, the same state you also store in a database. So first you start, all of us have been working within the state right now. All your applications, there is no storage in database. So when you refresh your page, your data is lost, right? Because all of it is being stored temporarily in state, and it's all local, like it's all in your browser. But in the next week, we are going to look at how to take that local state value and store it in the database. So every time when you change the state, we can make a call to the database and take all that value from state and put it in the database. That's what we do. So your application has to think about, when you interact with it, where should you store that data? Like by default, it's stored in state. But in some points in your development, you want to take that value from state and put it in a database. But once you put it in a database, it's there in the database. It's permanent, right? It's on your server. It's on someone else's computer. And you need a network internet connection to be able to pull that data. So when you load a page, when you refresh a page, for example, there is a function that what it does is it looks for information from the database and puts it into your local state, right? So there's always this like two-way flow communication in any application. So to go put things in a database, to pull things from a database and update the state. So the state is your local data source of truth, right? I hope this is clear. If it is not, just ask questions and I can explain it better. So you saw use state. So state is like a functionality to store data locally, right? So its purpose is to manage component state. And there are several different states that you have in React. You have use memo, you have use ref, you have use effect. Each of them give a very specific function. Use memo, what it does is it caches stuff. So caching is, there are certain things that if your application does repeatedly, like certain actions, you can cache some of those, either the values it created or like the result of certain operations. So you can cache them and then you can reuse them at some other point. So that helps, it saves memory, it improves your performance. And then you have use reference. So use ref is basically, you can refer to a button or a component somewhere and then use it elsewhere in your application. So you can be like, when that button is clicked, do this, right? So you can use that when the use ref and say, connect it to a button, and you can use it in any other place in your application. So you can move 10 things when this button is clicked. And you would use that by using use ref. Use effect is basically what I just mentioned, right? When you load your page, you need to bring the data from your database to your local. So the user effect. And this whole thing is called hooks. So you have all these React hooks. Hooks are basically like same as components, but not the UI. It's just the function, like just what happens behind the scenes, right? So that's what in React, you have a whole list of hooks that you can use. So how to read code? I think, yeah, question.
So, sorry, the cookie thing we have on websites would use memo as the hook, right?
No, cookie is actually a slightly different concept. Cookie, use memo might use cookies. I'm not exactly sure about this, but cookies, so for you to use memo, that's just at an application level, how you access information within that application. Cookies is what your browser uses as a feature to store information within your browser. So the layer of interaction of use memo is between you and your React app. The layer of interaction of cookies is between your browser and your React app. Make sense? So yeah, does use memo use cookies? Maybe. It's a good question. I don't know. Good to find out. But yeah, I can look up and tell you. Yeah, Nicole. Oh, you said something. Okay. How to tell a function from a variable? Okay. Oh, there are lots of questions. Okay, what's const let? I think we spoke about it. Where's your cursor? Okay. Can you explain the definition of props? It's the short form of properties, and it's just like information being passed from the outermost component to innermost component. And every component comes with definitions on what kind of information it needs. And that's why it's called props. So for example, a counter component, right? Like a stepper counter component needs a prop for the count number. That's it, right? It needs a prop for, if you have a counter that has more things than just a count number, all of them are individual props. So every component has these props to say that it expects all these values for it to do a certain operation. Yeah, Figma variables, yeah, variables are like the same as the variables that we spoke here. Nicole, did I answer the question? Is there anything unclear? Okay, so let me know, Nicole, if it is not.
I wanted to understand the state and database once again. Like, I think I understood the basics, but maybe I want to like check if I know it correctly or not.
Sure. Okay, so yeah, there is data that's being stored on your application, on your browser, and there is data that is being stored on your application or browser is just temporary. So when you refresh your application, all the data is lost. So when you interact with your application, you create new data, and this new data is stored on your browser. Does that make sense? And now, if you don't want to lose that data, you want to put it in an external database. So that's why what you do is you write a logic to go take that data from your local and put it on a database, right? So where is it stored locally? And that's called a state. Like it's stored, the whole storage mechanism locally is called a state. It's the state of the application. The state of the application is with full data or like no data, right? And your state keeps changing. As you add more data, your state keeps changing. So it's like, what is the state of the application? It is like how much data it has already, right? That's why it's called a state. And when you go make some changes, and when you click a button, say submit, and you want to store it in a database, what it does is it takes that information stored in the state, exactly puts that information in a database, and then saves it. Okay, so yeah, you need to you just need to know that when you create a database, when we come to databases and when we start defining like how a database looks like. You just need to know that it's taking the same thing from the state and putting it in the database. And also when you're loading the page, it takes from the database and puts it in the state. That's it.
Okay. And this data, what we are talking about is that is if somebody comes on that web page, whatever information they enter, is that is
Yes.
the that we are talking about, or that the pizza 1 2 3 what is it called, that is also the data we are talking
Yes.
about?
So I'll show you what all is stored in state, right? So right now in the state, the name is stored in the state, for example. All these different cards are stored in the state. What are the cards? What are the text inside this card? All of it is stored in the state. Everything that you see here is right now stored in the state, right? Is closed. See, for example, okay, so when I open this, again, this data is now stored in the state. And now when I hit on copy prompt, it's a function. That function just executes this copying to clipboard. That's what it does. And then when you edit this thing, right? Let's say right now this is not editable, but like when you try and edit this text, that edited text is stored in the state. So the state is modified to fit into the edited text, basically, right?
Yeah, thank you.
Yeah. So this is where like all these concepts of like real-time editing and all of that comes in Figma, right? Like you see how multiple cursors can all operate together. That's because the state is being updated real time in Figma. So when in your screen, when you're like moving the cursor within your Figma, the state is constantly changing in terms of where the cursor location is. And the same thing happens in someone else's local state. And then what they do is they write this function to real time pull the state from someone else's cursor and your cursor and show both in one thing. Does that make sense? So all of this works in combination. Like your local state and your database state, all of this works in combination. That's the real time. It's a bit advanced in terms of you would never have to do this. There are like packages that come to do this for you, but this is what happens behind the scenes. There's always a local state. There's always a database, and it's just about how do you pull and push information from your local state to your database. That's it. Okay, so let me keep moving. We completed this. Yeah, how to read code, right? I think we covered this for the most of the part, right? So this is your tree structure. Like within, if I open anything, you can just go. This is my header, right? So my header was, so this is let's say this is the whole header component, right? So it has a sign-in button, it has a cart button, it has this one, it has a logo. So if I go into my header, and you can see that, okay, these are all imports. Don't worry about imports. It's importing these components and it's using somewhere in your application. That's all it needs. So export function header is basically, this is the entire header. So everything inside this is the header, basically. So within the header, you can see that it's creating several different variables. So it's saying, I want to know if the menu is open or not. I want to know if the cart is open or not. I want to know if the loyalty model is open or not. And each of them has a default value. It starts with false when it's not open. But when I click it, the state will get updated to true, and then this will get updated to true. So, and then when this is true, wherever it depends, like on your application, there's a dependency on if the menu is open, do this. All that will automatically refresh. All that will automatically reflect based on the change in this value, right? So this is like a variable, and wherever this variable is used, when the value of the variable changes, all of that will also change with it. So it's linked. So everything is tied to this is menu open, and when you change this, everything changes. And yeah, so you create all these like different variables, and then what use effect is a hook that it's basically a functionality that happens when your page loads. That's what this use effect does. And then there's a couple of use effects. Now there's toggle menu function, the menu thing that just like changes. This is a syntax for just changing from true to false. So it's saying set menu open, which we got here, set menu open. It's saying when you toggle the menu, change the set menu open thing from whatever it is currently to the opposite. This exclamatory means if it is true, make it false. If it is false, make it true. That's what this exclamatory thing means. And yeah, so yeah, you can see so many different functions. Get loyalty button content is a function. and then you're executing that function here. And then get render auth component. Like you can just go through your code and you can see, and this part, when it goes to the return part, this is the UI. The UI is always inside the return part. So you can see like all of this UI part is defined here, and this should look familiar to you because this is HTML. And within HTML, you also have like certain components. You may have somewhere in your thing here, see menu is a component. So you're importing menu and you're using as a component within your HTML. So yeah, so this is how you like read your entire code. So, and then you have your cart model component over here. And these are the props. This is the cart model needs these information. It needs to know if it's open or closed. It needs to know on close what it should do. Yeah, so if you close the cart, it executes this function, and that function, what that function does is it sets the is cart open thing as false. And when basically that is cart open thing is over here, right? There you go, is cart open thing, and you say create this function called is cart open, which just sets the value of cart as true or false. Yeah, that's basically does what happens under the scenes. So why do you want to know this, right? So let's say you want to make changes to just the text. So that's why you can go and confidently know that this is all the UI part. So within the UI part, you can just go be like, I just want to change this text. So you can just change it directly. Or you can just highlight this, hit on Command K, and just say update the address to something else. And then it will just go update it for you. So you don't have to go through this agent and use up a lot more tokens. You can, if you know how to read code, you can just do it right here. Okay, how do you pick good hooks and packages, right? So you can see the website called npmjs.com, and you can see all kinds of packages. So if I open this React confetti package that I use, you can see the number of downloads, you can see what's the homepage, how many people have liked it, and all of that stuff you can see here. And that's how you know if you're using a good package. So the better packages you use, the less buggier your application will be, right? So for example, this has 1.6K stars. That's actually pretty big. And yeah, so this is a React confetti package with which I implemented this confetti animation that I just showed you. This confetti animation that I created was just using this package. I just said, look, use this package. And when I click on copy prompt, just throw that confetti out. That's basically what I did. Look for a number of downloads, look for recent updates. If it has good documentation, it probably is a good package. Okay, so in terms of assignment, right, it's very simple stuff today. So all you need to do is just go understand how your application is architected, right? So there's a component called React Chrome extension, React Debugger, I think, Chrome. And yeah, so you can just React Developer Tools. So you can download this extension. And what this extension does is it helps you see how your component packages are organized. So if I open this one, it'll have this red color thing on top. When I open my inspect element, same as we spoke last time, if you go here and click on components, you can see how your entire component is arranged in your application. So it starts with the app, and then it goes, all of these context providers are just like information being passed down. And then this is all the router component. And then these are all the different UI components. There's a sailboat, there's a brain, there's a timer. So yeah, all these components are, you can just go through it and try to understand what React components are. If you don't understand, just copy this or take a screenshot, put it into ChatGPT and ask, okay, explain to me how this works. So try and get a better understanding of it, right? And the other thing is how the data flow. Like I explained how the props go from outside to inside. You can see that also from this component. So you can see, let me open this again. If you click on this data, you can see that these are the contents being passed as props. So the data component name is app, this is the path, and then there is like this component line and all of that. So if I open another sailboat component, you can see all of this information being passed as props. So you can see how your data flows from outside to inside. You just go and observe how this thing, so that your concepts of like how React works is clearer. And yeah, as usual, document what you learn, because yeah, it helps for you to later reference to it. Some quick tips. it's useful to decide when you want to use a package or when you want to code from scratch. This is very important because it's a decision that you're letting AI make for you. You're saying either if you don't say anything, it could choose on its own. It could just create something from scratch. The problem when it creates something from scratch is it won't create a robust version. It'll create a basic version. So when that happens, you can be like, hey, don't create something. Why don't you just use this package instead? And that will instantly give you all the functionality that you want in your application. So that's where you can make a decision for AI and be like, look, use a package for this. Use better packages. Don't use unmaintained packages. Go look at the packages that are there before you know which packages are being used. You can also go into your package.json and see all the packages that you already have. If there are packages that are not good, just remove it. You don't need it. Yeah, you need rendering logic, right? So the way, if you have better, not too many functions that do the same thing, if you have whatever I explained, if you take that into consideration, your app will have better performance. So this is going a little more into the advanced because like when you have, after you've gotten everything, like all your logic, and sometimes your app will like not perform as good. You'll be like, you'll have so many issues, like so many unexpected times it'll break. So that's where you will apply all this learning, make sure everything is neatly done. Yeah, Sriraksha.
How can we play around with this rendering logic?
It's like rendering logic is just what I said about like functions and variables, right? So you can be like,
Not
hey,
duplicating them.
exactly, not duplicating them. State management is a rendering logic, right? So you can ask and understand, is this information being stored in the state or is this information being fetched from the database? Because when it's being fetched from the database, it's slower because it needs to go access through internet. So you can be like, at this point, why don't you just operate all on the local state? Now, only when I hit a submit button, go do the database stuff. Don't do the database stuff all the time, right? So you can say things like that. And that's just a rendering logic. So it makes decisions for you, and hopefully it makes the good decisions, but it's good for you to understand and decide and make your own decision as well. Yeah, and your package version, don't change anything. If you go into your cursor, you can see for every package.json, you can see every package has a version number. So it's very easy to think that, okay, you know what, let me just get the latest package because it'll have the best functionality. No, it doesn't work like that because each package depends on other packages, and as long as it's the same version, it'll work. So every time you update a package to the latest version, the chances of it breaking is like quite high. Yeah, that's it. And next week we can talk a bit more about databases and like how from your local system, let's say you're doing the like this from location into location in your application, for example. How do you want to store that? How can you store that in database? We'll talk about that a little more. And we'll also touch a bit on state again in the next section. Yeah. Cool. Was this super technical? Any feedback?
Was technical, but I think you made it very easy to understand with good examples.
Okay, cool. Thank you. Yeah, I think you'll get this better when you start examining your application and then try to understand what's happening. Spend some time with like ChatGPT and try and understand, because when you ask ChatGPT what's happening, it'll tell you things in the language that I just taught you so that you'll understand it better, like what's exactly happening, right? And try to ask it more questions to get more clarity on what's happening. So that'll give you the foundational understanding you need. And this is getting very important for us to know because this vibe coding is becoming a standard thing for designers in companies to start using. And these concepts are essential for you to know if you want to work with others, if you want to make this a standard practice. Yeah, that's pretty much all we had in the agenda for today. So 5 minutes over time. Cool. Any last questions? Anything else?
No.
Right. Cool. No worries. Okay, cool. Then enjoy your weekend and see you next week.